So the next section has to do with graphing logarithmic functions, and we're going to, again, skip that right now and jump to part D, as in delta, two special identities. And the special identities are 1, I'm just copying this from the book, B with log up in the exponent position equals x. Oops. I need an X there. And 2, I'm going to put the 2 over here. Log with a base of b with a b, x is an exponent equals x. Okay, so these are two very important identities to have in your notes. That if you have a number and the log with a base of that number to the to x, you're going to get, everything is going to cancel. So if you have b and a log of b in the exponent, all of this cancels and you just get x. If you have this here, log with a base b and a b here, this cancels and you just get your x. So we'll do an example or two of these just so you can see what happens. So example 5, we have an A, B, C, D, E. We have a log. This is A. Okay. So if we have that, we're going to, again, substitute our 8 with that. So look what we have here. We have a log with a base of 2 at 2 here, right next to each other with an exponent of 3. That's what we have here. A base and our b, these two are the same, so our answer is just x. So we don't have to do anything there. We just switch it to 2 cubed and we get 3 for an answer. If we were to do, let's see, we erase this stuff. We do b. B says the log with base 10 is 10,000. So 10 to some power is going to give me 10,000. And that some power ends up being 4. But let's write that in one of the two identities they gave us. So first of all, we're going to write this as log 10. But can we write this number here as an exponent? We can. So then it's, again, similar to this one. These two numbers are the same right here. And our answer is just our exponent. Okay? So what this actually is saying very simply is 10 to what power is 10,000? 10 to the 4th power is 10,000. But we wrote that 10,000 as 10 to the 4th power so that we could use this identity. All right, let's look at, what is it, C. We've got log B, base B, like that. Okay, so we look at that, and this can be written as, if we can write this with an exponent, that really saves us a lot. B can be written as b to the 1st power. So again, it looks very similar to that, so our answer is 1, this exponent right there. So again, as you're doing these, try to remember that you can write these. If you can write them with an exponent, it's going to make things better. All right, log with a base b. Okay, so what exponent can I put on b that's going to give me an answer of 1? Now, this is not really too terribly much rocket science, because any number to the 0 power equals 1. Any letter to the 0 power equals 1. So what I'm going to do, if I can write 1 with an exponent, what would that exponent be? It would be a 0, because 1 to the 0 power is 1. So I can write it that way. So that ends up giving me a direction, but I can also make this a b, because b to the 0 power is also 1. So I'm trying to find out how I can make these two numbers the same so that I can find out that my exponent that I put on this number is going to be my answer. So if these two are the same, the exponent is the answer. So a lot of these are not really tricky as much as you're just going to have to think through what you're doing here. Okay, so log, and it just takes practice to get to the point where you can start seeing this stuff. Now remember, PEMDAS says we're going to do what's in the parentheses first. All right, so I can see that these two are the same, just like this here. These two are the same. So that means this answer is the exponent that's on the 5. Well, what is the exponent on the 5? The exponent on the 5 is a 1. I mean, if it was a 2, it would be 25, not 5. But since it's 5 and that's where we're at, it's 5 to the first power. So log of the base 5 is 1. So now we're going to put that in instead of the parentheses. Log with the base 4 of 1. Okay, so now we're looking for a number we can put on 4 that would give us an answer of 1. So 4 to the what power equals 1? Well, just a little bit ago, we determined and reminded that a number to any power, or to what power equals 1, that number will always be 0. 4 to 0 power equals 1. 3 to the 0 power equals 1. F to the 0 power equals 1. So that's telling me that my x here is going to be 0. Okay? So those are 5 examples, and we'll get into a few more of these in the homework, because that's as far as the lesson goes, but I think it's important to try some of these homework problems just to remind you of, just to give you some extra help and extra practice. Okay, so let's look at the problem set 8.3, 679. We already did some 1 to 24. Let's start and do some that are similar to 25 to 46. Well, let's actually do some of those. So if we did number, say, 30, we've got log 3, 27 equals x. Okay, so the first thing you're going to do is write this in exponential form. Because we have this equal sign, we want to write it in exponential form so that we can solve it, and that equals 27. Okay, so we're trying to find out what number multiplied by itself 3 times, or 3 multiplied by itself x number of times equals 27. So remember, we're going to see if we can write our base numbers the same. If we can write 27 as a 3, that will help us. And then we can just look at our exponents and make them equal, and there's our answer. So 3, basically what this logarithm says is 3 to the third power equals 27. So we are able to solve for x. So that's when you're using logarithms a lot, is when you're trying to solve for the exponent, if you don't know what that is. So let's do one like, let's do 32. Log with a base of 25, 5 equals x. So that says 25 to the x power equals 5. So again, if we can write this base as a 5, that will help. So I'm going to write it as a 5 squared, and then I'll tag my 2 or my x on there. So it's 2x equals 5 to what power? 1. So my 2x equals 1. So x equals 1/2. Or basically, so what I've got here is 25, if x is 1/2, that equals 5. Well, what is 25 to the 1/2 power? 25 to the 1/2 power is the same as the square root of 25, and that does, in fact, equal 5. Okay? So the key on doing these is to figure out the method that you're going to solve these. It's simple algebra, but it's trying to figure out the doggone method in order to make it work. Let's try one like 40. There's a couple of them like that. So we have the log of x to the 1 over 25 equals 2. So that says that x squared equals 1 over 25. Okay, that being the case, in order to find x, we take the square root of both sides, and we get x equals, the square root of 1 is 1, square root of 25 is 5. So that's the number we get. So if we were to write this in exponential form, it would be 1/5 squared equals 1 over 25. So 1/5, which is our x, squared equals 1 over 25. Is that a true statement? 1 times 1 is 1. 5 times 5 is 25. So yes, that is equal. So when you're doing ones like 40 through 46 with those fractions, you've got some things going on there that hopefully that'll make it easier. Okay, if you look at number 65 on page 680, as we kind of go over a few of these problems here, there's a couple ways that you can solve this or look at this. You can look at this as exponentially 3 to, if we make this equal to x, because we don't know what exponent we're going to put on this 3, but we're going to write it as 3 to the x power equals this 3. So these two numbers are the same, so our exponents are the same. So in order for it to equal 3, this has to be a 1, right? 3 to the first power. Therefore, x equals 1. So that's one way to look at it. The other way is to use the identities that we had looked at earlier, where if you can, let me erase this here, if you can take this number and put it into a form where it is equal to the base, do it, and your exponent is your answer. Well, the exponent up here is 1, because 3 to the first power is 3, and these two are equal, so our answer is just that 1 there. So either way works. I prefer probably the first way I did it, because I have a hard time remembering all of these identities. Okay, so let's look at 69. Log of 17 of 1. So what that's saying is 17 to some power equals 1. All right, so what do I do with that one? I try to figure out what number I can put in here for x to where I take 17 to that power and give it a 1. The salvation of all this is if that exponent is 0. 17 to the 0 power is 1. So that's just looking at it and being able to say, oh, pretty simple. If I just remember that fact that if the exponent is 0, the answer is always going to be 1. Okay, last example I'm going to do for you is number 81. I hate it when teachers give you all the easy problems for examples and then give you the hard ones for homework. So let's take this very last problem here that I'm assigning and do it together, because it looks tricky, but it's not. We just look at each piece at a time. So we're going to start with the innermost parentheses. So let's just do log 2 of 16. My dog just opened the door, so let me shut that here. Okay. So we're going to say that 2 to some power equals 16. And remember I said if we can make this base and this base the same, life is good. 2 to the 4th power. So that means my x equals 4. So that means that the log base 2 of 16 is 4. So now I've got log, just going to rewrite this whole thing again, log 2, and I found out that this is 4. Okay, so that's where I'm at now. So let's look at this one. Let's do it in red here. So 2 to some power equals 4. Okay, 2 to some power equals 4, because if we have an equal sign here, if I would have written this as equals x, then that's why my exponent is the x right here. So I'm going to write this again so that our bases are the same. So x equals 2. So that just got rid of that part. So now what I have left is just this. So log base 4 of 2, and I'm going to make that equal to x. So 4 to the x power equals 2. Okay, so far, so good. I'm going to make these base numbers the same so that I can compare the exponents. So 2x equals 1, my exponents here. So x equals 1/2. Okay, so the answer to this big old long drawn out one way up here is just 1/2. You just do one piece at a time. You just basically what we did is we did what we've been practicing on 3 times in order to get the answer. So that's it for 8.3.